So suppose the members of the Indians, right, think they can win 55% of the time on any given day. By the way, what letter am I going to use for that 55%? Absolutely. That little p, right, is going to be 0.55. What about Q then, automatically? 0.45. And what about N?
3. Was this about to be 5 or 3?
Well, that's the question. I guess my idea was, let's first do the computation for n equals 3. Okay? And then let's do the computation for n equals 5. Hey,
It
Joanne.
was better for me when I did 3.
Okay. Well, we're going to do both. We're going to do both. So n equals 3. How do you win a series of 3 games? How many games do you have to win?
2.
So we have to compute the probability that x equals 2. But I'm going to tell you something. If you compute that, you're going to say, hey, wait a minute, because I think you get something less than 50%. Right? You say, wait a minute, I thought this was the better team. Well, that's because you have to add to it, and this is what I was trying to get at. You also win the series if you win all 3 games. Now, you know what's funny about baseball is if you win the first 2 games, guess what? You're not going to play the third game, are you? So, but you still need to take that into account when you're computing probabilities. So basically, what are the 4 possibilities? X equals 0, x equals 1, x equals 2, or x equals 3, right? And what we want is for the best of 3, we want to compute this probability, that probability, add them together. Are you with me on that? Then you guys will do the problem again. What is it you would want to add together, or how would you do the computation for n equals 5?
Minus 3?
So let's say that, I'll use y for the n equals 5 case, just to be different. And what I'm going to say is, let's compute the probability that y equals 3, the probability that y equals 4, and the probability that y equals 5. And that's all the different ways that you can win a series of 5 games. You have to win the majority of the games. You guys with me? Of course, I tried to mention there's shortcut. There's kind of an alternative approach also. What's another way you could do this problem? Yeah, that binomial CDF you may want to try, because what that might do, right? Because what you're supposed to do here is compute the probability that y is bigger than or equal to 3, right? Well, you could say that's 1 minus the probability that y is less than or equal to 2. So this is another way to do it. You either add up these 3 or you explore this possibility. Okay? And you have the binomial formula, and you have n, p, and q. I think maybe that's enough of a hint, all right?
What do I use for my trial? 3 or 5?
When you do this, I want you to use 3. But then I want you to go back and try it for 5, and we'll compare. Okay? I'm going to pause and walk around and try and give more hints if you guys need them. And I'll also be looking at homework. If you guys have homework, you can take that out, and I'll be taking a look at that. We have a 5-game series. What's the probability that we win? Right? That's what you're asking.
Would it still be 1, 2, or 3? 1, 2, and 3 should be done. You should have to play for it.
I'm saying if you say 1, you don't win if you only win 1 game. You don't win the series if you win 2 games. You do.
3.
Well, okay, now I understand that confusion. Because you're going to say we wouldn't play 4. But what if you did? See, the Indians, how many games did let me do a best of 3. Up here we're doing best of 3, right?
I really hope you're going to put like a game situation on the quiz tomorrow, because if you do something else, then this is not going to make sense.
I hope whatever I do, you try your best on the quiz and not worry about it.
So what's my grade tomorrow?
What's that?
What's my grade tomorrow?
Let's see what happens. I'm trying my best to help you guys. I'll tell you what, though. I would not put this kind of problem on the quiz because I think it's a little too abstract. I mean, it's too wordy. Do you see how much I had to kind of say besides what's written to get everyone to understand it? That wouldn't be a fair quiz question. I don't
We
think.
wouldn't have that question at all.
No, but will we have questions that have binomial distribution? Oh, absolutely. But I don't think it'd be fair to say, well, like this. Hey, which system should they support and justify? Now, that's a good homework question or a project question or a discussion question like we're having right now. I don't think that's a good quiz question. Okay? But yeah, you'll have to do some binomial stuff. So, this was just the idea. Hey, how do you win 3 games? How do we win the series against Texas last night? Because we did what? We did this, right? We won all 3. What else could have happened? We could have just won 2. And by the way, did anyone compute the probability when x is 2? You guys did? What do you guys get? Oh, actually, Dylan, can I borrow yours? This is nice. Pretty nice presentation. You know, my handwriting's so. Check this out. No, I liked it. Okay. So his probability that x equals 2 is computed right here, and he got 40%. Did anyone else get about 40%? If you did, that's good. His probability that x equals 3, but let me point something out, by the way. What's the chances of the Indians winning 2 games? 40%? That's not good. If you thought that was the answer, you'd say, well, wait a minute. We're probably going to lose the series. But that's not true, right? We know if we're the better team, 55% chance of winning any game. So that's interesting, right? Chance of winning 1 game is 55%. When he adds the probability x equals 2 plus the probability of x equals 3, what's he get? 56%. You're a little more likely to win a best of 3 series than just a single game. Does that make sense? More games is going to favor the better team. Then, this was kind of nice. So guys, I guess he worked it out using the formulas. What's another way you could get the same thing? Like, what's another way you could get this 40%? You could do, and we did this on the calculator, binomial, do you remember what you have to write? Binomial what? PDF, that's right. Binomial PDF. And then you need to tell it what n is, so it would be 3. You need to tell it what the probability little p is, and for us that's 0.55. And then you would need to tell it how many wins we're talking about. So this one was 2, and he got 4. That's another way to get the 40%. Okay, so I showed that yesterday as well. Anyways, when Dylan added up these, he got 58%. And that kind of shows you that the best of 5 is kind of better. Actually, I want to write those numbers down and come back to it. So we had 0.33, we had 0.20, and we had 0.05, right? So that's a binomial PDF. And one of the reasons I want to do this is I want to talk about the other way I suggested coming up with the answer. I said that another way to do this, see, the probability of winning, this is what Sarah asked, what is winning? Winning is when you get either 3 or more games, right? So one way to do it is just do 3 plus 4 plus 5. But the other way to do it, I said, is the complement. See, if you don't win 3 games, how many do you win? Either 2 or maybe only one, or, right? If one of these things happens, I put it in red because guess what happens then? You lose the series, right? If you only win one game in the series, you just lost that series. But what I'm saying is there's a fast way to do this. What was that called? Not binomial PDF. What does C stand for? Cumulative distribution function. That's right. Cumulative means you add it all up. So we could do 1 minus binomial CDF. Let me work that out for you guys. So you guys, I just want to remind you how to do it. So if I go to my calculator, here. Oh, I don't have that. Oh, well, it's got to load. The other thing I've been thinking of doing is showing you how to do it on Excel. Remember the Excel stat? If you notice, we haven't used that in a little bit. Good? All right. Tell you what, since it's the day before a quiz, unless I run out of things to do today, I'll stay away from that. Okay? I do want to show you, because for the final computer project, one of the things you'll have to do is you have to go back through each section of each chapter and be able to do something from it on Excel. It's kind of interesting.
I'm sorry, do we have more than one option for that?
Oh, yeah.
I hate that Excel. We went through it so fast. I already use Scan.
It's one of the reasons that I think that it's easier to pick up on the calculator than Excel. I think so. But which one's more useful in the long run? That's why I made it a final project as opposed to each quiz having to use Excel.
Are you going to go through the details of what we're doing in the project?
Not today.
Well, but like.
Yeah, in time. I'll tell you what you're doing, but not today.
We have about 4 weeks left.
Yeah, 5. Yeah. Yeah, we have 5 weeks left.
5.
It's an 8-week course, right? We're on week 3. Okay. Yeah, one thing you guys should know is that the finals week, we're not really in finals in this class. We just meet every day, 8 o'clock, just like normal. Okay. That's how the schedule works for the P2 classes. If I gave a final exam, I'd have to give it like that last day. I'm not giving a final exam. I'm just going to have you guys turn in a final project. That's kind of what we'll do. Okay. So we might not meet that last day. Is what I'm thinking. That's no exam. All right. So, anyways. Where was I? Oh, yeah, I was going to show you guys how to... This is my graph from yesterday for my calc class. All right, so I was doing some stuff. Oh, yeah, binomial CDF, right? Because what I'm trying to show you is another way to do this probability. 1 minus binomial CDF. So let's see, what do we get? Binomial CDF. How do we get that? Hit the second button and then go where? Yeah, distributions, right? And then I'll hit the up arrow, right? Yeah, it's choice B this time, right? Binomial CDF. And so my calculator says how many trials do I want? Now I'm going to clear out 300 because that's too many. We want how many trials? Thanks, guys, for your participation. It's outstanding. Thanks. 5. I was like, what? Who am I talking to? What's little p? 0.55. And then the x value would be... Let's look again. Here it is. I'm computing the probability that y is less than or equal to what? 2. You want to put what it's less than or equal to. So I'm going to put 2. And what that'll do, this will very quickly add up these 3 probabilities. It'll add up. So if I show you, we got about 41%, right? 40.4068. So what that does is adds this up very quickly and gets 0.4068 is what we got. So it was binomial CDF of, we did 5.55 and 2. 1 minus 0.4068 is about 60%. I think it's 0.5932. So it's around 60%. And when Dylan did it, he got Oh, it's 59. I guess when Dylan did it, he got 58. So it's off a little bit, 59, 58, but it's close. You know why it's off a little bit is, well, maybe these are rounded a little bit too. It could be that if you added the extra digits like I did, you get closer to 59. I'm not sure. Okay? Guys, follow the ideas. Cool. So there's a couple other things we need to do today, and that is we got to review for a quiz, right? And I had more in mind when I looked at this problem because, you know, when you look at what the quiz is on, right? Let's just do a brief outline of what the quiz is on. Okay? So there's chapter 5 stuff and there's chapter 1 stuff. Chapter 5 breaks into the following topics. 5.2, okay, talks about probability distributions. Right? Whereas 5.3 talks about the binomial PDF, I'll say, probability distribution function, right? So I claim we covered that today. But did we do 5.2 yet? So let me go over a couple of things with you. How do you know if you have a probability, this PDF, how do you know if you have a probability distribution or not? Let's go ahead. So that's right. A probability distribution, you have x's and you have probabilities, right? But I guess the important point is these add up to 1. That's a very important idea. The fact that these add up to 1 is important. Also, one other thing. The other requirement, by the way, there's actually 2, is that the probability always has to be greater than or equal to what? 0, right? You can't have a negative probability. And I guess it also has to be less than or equal to 1, right? That's kind of obvious. If you have numbers that aren't in that range, you don't have a probability distribution function. You don't have one. So then, after we learned all about probability distribution functions in 5.2, 5.3, this is just a special example of one. Do you guys realize there's a lot of other ones? Let me show you. I mean, look at that calculator, right? If you hit second distribution, look at all the choices there are, right? We're going to learn about a lot of these as the course goes by. You could argue the binomial is not even that important. That's why it's like way down on the list. Okay? But I like covering it now because we can understand it. It's very understandable. This one here, choice 1, the normal probability distribution function, most important in statistics by far. That's why they make it number 1. That's tomorrow's lesson. Tomorrow's lesson, I teach you guys all about the normal distribution.
I have a homework question.
Yeah, about which section?
5.4.
Yes.
13.
Which number?
13.
13. Can I do one other thing and then get to it? Because here's what I did now. I wrote it down right here. Number 13 is my little note. I'm going to get to that next. See, there's one other thing we did about probability distributions. We learned how to compute the mean, which I also called the expected value. Remember this? But I want to remind you, because it's been a couple days, how do you compute an expected value? What's that? Well, that's only if it happens to be binomial. You're right. For section 4, this is all about expected value. Yeah, what was the expected value of a binomial? It's also called the mean. Mu equals, like Dylan said, n times p. But that's only if you have a binomial. In general, what's the formula? Here, let me show you. I have my formula card out. I will do the same thing, guys. I'll give you guys, just the chapter 5 formulas. I'll put them on the quiz. All right, where are they?
You will give us the formula.
Yeah, remember how last time I gave you just the chapter 4 formulas?
Yeah.
I'll do the same thing. I don't want you to sit there tonight memorizing formulas. If you're finished with all the homework, what I'd say would be better preparation, try the chapter 1 or chapter 5 quick quizzes, right? Or try there's review problems also that have video solutions if you want.
Where would I find those?
The quick quizzes and the chapter review,
Find that lab, yeah.
you go onto the book and go to the end of each chapter.
Okay.
The end of each chapter has them. Anyways, the formulas that I'm going to give you tomorrow, let's see. Not that, that's chapter 3. And last week I gave you chapter 4, but it should be, shoot, I just did it wrong. That's chapter 8, we don't want that. Okay, there's chapter 3. I think I'm going to give you kind of a close-up of this tomorrow. Yeah, chapter 5, right? There it is. Do you see the top formula? How do you read that? The mean is, mu. And what do? Sum up what? X times P of X. That's right. I want to practice that formula with you. Then I want to get to number 13. Okay? And I thought a great place to practice it would be, on this group work. Here, we did this. Matter of fact, Dylan has his paper back, but I know we already computed the probability that x is 2 and the probability that x is 3, right? Let me also compute the probability that x is 1 and the probability that x is 0 for the best of 3 series. Let me just do that. So again, I have x values and I have probabilities. Probability of x equaling x. So I'm making a little chart here. Okay? So let's see. It's getting sloppy. Let's make it neater for you. Ready? If I zoom in, that'll help too. Okay, here we go. I have x values, and I have the probability that x equals x. And so it was 0, 1, 2, or 3. And you guys worked this out. When it was 3, what did you guys get? 16%. And when it was 2, now you got 40 or something like that? 40%. I have to do 1 and 0. Let me work out 1 and 0. So let's see. How would I do 1? I would do binomial PDF, let's say. And this was the best of 3 series, right? 3, 0.55. And then what's the x value? I said 1, right? Okay, let me paste that in and see what I get. 33%, okay. And by the way, if I do the same thing with 0, I'm going to hit second entry and just change that 1 to a 0 to be really fast. I get 9%. Okay. Now, is it true that these add up to 1? Oh, not quite, right? If you guys add those up, I think they add up to 0.98. Oh, so is this a probability distribution function? Well, the only way it is if it adds up to 1, right? But you know why this happens? I think it's rounding error. I think we rounded. For example, if I just go a little bit more, a few more digits, I think it'll work out a little better. So let me do that. It was 0.3341, and it was 0.0911. And like when you do 2, let me just redo it. What was the number with 2 wins? 0.4084, because I'd have to round. See, I would round that up to 41% if I were just doing 2 digits. And to finish the chart, we got to change that 2 to a 3. I just want to get good results, so I want to round carefully. 0.1664. Okay. 1664. Guys, if you add all these up now, you get 1. Okay? This is now the way it's written. This proves that we have a probability distribution. Right? Yeah? Okay. So what I wanted to do next is I wanted to find the mean. Hey guys, what's the average number of wins that the Indians will get in a 3-game series? That's kind of what I'm answering, right? What do you think it's going to be? 2? That means they'll usually win, if that's true. Well, let's see what happens. So to compute it, we're supposed to use this formula. We're supposed to sum up x times p of x, right? Well, I need a column then here for x times probability x equals x. So let's make a little column. This example is so small I can do it very quickly. Guys, what's 0 times this? Nice job, guys. What's 1 times 0.3341? You guys rock. What's 2 times 0.4084? Well, I guess it would be 0.8168, right? You can see that. And now the hard one. What's 3 times this? All right, I'll do it, 48, 40. Well, let me do it backwards. 3 times 4 is 12. 19, Gary 1. I got 0.4992. Let's add all that up. Well, I got that the mean number of wins, the mean is 1.65. Does that mean I think the Indians are going to win 1.65 games out of 3? No, of course not. By the way, what do you think would be the mean if the chances of winning were just 50%? Like if you said the teams are totally even and they're playing 3 games. Do you know what the mean would be? 1.5 is right. That would be the middle if the teams were dead even. We're saying the Indians here have a 55% chance of winning any game. And that's why the mean gets pushed to the right a little bit. It's 1.65. Now, they'll never win 1.65 games. They'll either win 1 or 2, or sometimes 3, or sometimes 0. But in the long run, the law of large numbers says the average would be 1.65. Do you guys understand that?
Yeah.
Now, this goes to Sierra's question. Because in 5-4, we have very easy formulas for what? For binomial PDF. And so the very easy formula we could use for this problem would be that the mean is equal to, as Dylan told me, n times p. Let's try that. What's n for us? 3. And what's p? Well, it was 0.55, right? Here, check out what I get if I do 3 times 0.55. I get 1.65. I'll tell you what, guys. That's really close to what I computed here. 1.65. You see what I'm saying? If you have a binomial, the formulas are really easy. The problem is most of the distributions we're going to cover are not binomial. I showed you guys that list, right? No? Yeah, I did. I mean, by the time we're done with this course, it's amazing how much you're going to understand about this calculator. Not to mention Excel. Because you start in, you're like, man, this thing is totally foreign. But you see all these different commands? They're all different distributions. For each one of them, you might want to know what's the mean of that distribution. Well, we're starting to get an idea of how that works. Okay? N times P doesn't usually work. It does for binomial. That was the whole point of that section. Sierra, you asked in particular about number 13. Let's do that. Let's go to the section 5.4, number 13 together. And then I have a couple more problems I may look at. We'll see. What page? I had it.
Starting on 255, so maybe like 227, maybe.
227, I'll try. All right. Let's see. Yeah, perfect. Nice job. Okay, so cell phone problem. I remember this one. Do cell phones cause brain cancer? So looks like they sampled a whole bunch of cell phone users in Denmark. 420,000 cell phone users. It was found that 135 had developed brain cancer. Very sad. That's less than 1%, though, right? I mean, it's not very common. If we assume that the use of cell phones has no effect, oh, I see, they worked it out. 135 divided by 420,095, is that what they did?
That's where they got the 0.
Okay.
I got that. But when I got to A, B, and C, I was just like...
Okay. So it says, Part A, assuming that cell phones have no effect on developing cancer, find the mean and standard deviation for the number of people in groups of 420,095 that we would expect to have cancer. Okay. Got it. Here's what they're doing, guys. They're saying little p should be this number.
Yeah.
That's little p, right? So basically, oh, this is a horrible thing to write, but I'm about to write it. X is the number of people who have cancer. N is 420,000 what? 095. They gave me little p. What's the probability of someone having cancer somewhere, I mean, just in general? People already knew that, so they gave it to me. 0.00, yeah, I said it's less than 1%. It's way less.
Yeah.
0.00340. So if we say x is binomial, right? Would it be binomial? Let's see. You either have cancer or you don't. So there's two possibilities. Success is having cancer, and I don't know about that. But that's kind of what we're doing, right? We're saying this is your chance of having cancer. So then what we can say is the expected value of x is n times p, right? So we have to take those two numbers and multiply them together. Let me work that out. Let me see what you get. I'm just curious. So 420,095. Oh, shoot. I don't want to be there. I want to be on the home screen. Okay. 420,095 times 0.00340. Okay. So we're getting... Thank goodness. Because, wait a minute. Let me see that. You guys said 0.000340. Okay. So we'll try again. I need another 0, you're saying, Dylan? Yeah. 0.000340. Yeah, okay. So what's the expected number of people that should get cancer in Denmark? 142. How many did get cancer? What was it? So what do you think? Does this indicate that cell phones cause brain cancer or don't? I mean, you're getting about the expected value, right? We predicted 143 if I round, and they got 135. I mean, you have to understand something about expected value. It doesn't mean we expect to get that. It means we expect we'll be somewhere around there. So I would say the answer to part B is, no, this doesn't prove that cell phones cause cancer. What if when you did the study, you found 500 people got cancer? At that point, they might start banning cell phones, right? Or making it, with a warning label like cigarettes. You see what I'm saying? But if we only got 135, no, that's about what we expect in general of the population. Okay. Wow, time flies. 9:15. Let me tell you what I didn't have time to do.